I will have to find the current through the 56 volts voltage source using mesh analysis in this case. So first I will assign mesh currents. There are three meshes here. So let's call it I1, this one I2, I2 there, and finally this one I3. So three mesh currents. So I will write KVL for each of the meshes. So first I am writing for mesh 1, which is this one with the mesh current. So on the left hand side I will write the voltage drops. So for 2 kilo ohms the current is I1, then plus 6 I1 minus I2, because I2 is going on the other way, and so I am assigning the drops this way for this one and like that, and it's going counterclockwise. So the current will be 6 into I1 minus I2, because I2 is going in the other direction. Similarly, for this 4 ohms resistance, 4 I1 minus I3, and on the right hand side the voltage source, which is, if I go this way, not because of only voltage source, but going in the counterclockwise direction, this is a rise, so rises on the right hand side, 56 there. So if I rearrange, it becomes 2 plus 6 plus 6 I1 minus 6 I2 and then minus 4 I3, and on the right hand side it's 56, so that becomes 12 I1 minus 6 I2 minus 4 I3. Now if I observe something here, what I can see, the coefficient of the current I1, which is the mesh current, is the summation of all the resistances here. So 2, 6 and 4, these are summed, and that is the coefficient of I1, 12, and the other two currents, the other two mesh currents are coming as negative, and the coefficient of those is the coefficients of those are like, the for I2 it's 6 here, and 6 is the resistance that is common between mesh 2 and mesh 1. So the mesh 2 current is coming as a negative, and the coefficient is the common resistance between these two meshes. Similarly, the common resistance between mesh 3 and mesh 1 is 4. So the mesh 3 current is coming as a negative current, and the coefficient being 4. So this is, by observing, we actually directly can write the mesh equations for uh, each of the meshes. So what I will do, for mesh 2 I will write the equation directly, and on the right hand side I can see, for mesh 1, right hand side is coming the EMF. So for mesh 2, when I start writing the equation for mesh 2, for mesh 2 the current is I2, so I2 will be positive and I1 and I3 will be negative. So first it's negative I1, and the common resistance between I1 and I2 is 6, so that will be 6, my negative 6 I1, and then plus will be the sum of the three resistances, so 6 here, 6 here and 2 here, so that's also 12, so 12 I2, and negative I3, but the coefficient will be here, the I3, the common resistance is 2 ohms, so that's 2 I3, and on the right hand side will be 0, since there is no rises there is no voltage rise in the loop, in the mesh. And then for mesh 3 the current is I3, so I3 will have the three resistances 4, 2 and 4 added, so that's 10, so I will write that first, 10 I3, and then minus I1 will be the common resistance between 3 and 1 is 4, so that will be 4 I1 there, and then 3 and 2, the common resistance, mesh 3 and mesh 2, the common resistance is 2 kilo ohms, so that will be 2 I2. So, and on the right hand side again it's 0. So these are the three mesh equations. There's a little bit of mistake here, it's not 12, because 6 plus 6 plus 2 is actually 14, so it should be 14 there. So I have the equations. Now I need to find basically I1, because that is the current through the voltage source. So I1 will be, in terms of determinant, I can write in the denominator will be this is from the equation. So the coefficients, so 12 minus 6, 12 minus 6 and minus 4. The second column will be minus 6, 14 and minus 2, 14 and minus 2, and the third one will be minus 4, minus 2, 10, minus 4, minus 2, 10. So essentially the first column is the coefficients of I1, the second one are the coefficients of I2, and the third one is the coefficients of uh, I3. And on the numerator will be, since I am trying to find I1, the first column will be the right hand side, so 56 0 0, and the other two columns will be the same. So sorry, that is, there is no negative there. So 14 and minus 2, minus 4, minus 2 and 10. So now I need to solve this determinant. So what I will do here is, in the denominator will be 12 and 14 10. So 12, 14 times 10, 140, minus, that will be minus 2 is plus 4, so like that, and then negative of negative 6, so that will become positive 6, and then this one, so this one multiplied by this one is negative 60, and negative of minus 4 times minus 2 is minus 8, so plus 8 basically, so minus 8 it becomes, and then finally the third one is 4, minus 4, so that is 6 times 2 minus 6 times minus 2, that's 12, minus is 14, minus 14 times minus 4, which is negative 56, but minus, so it's become positive, so plus 56 there. So that is the denominator, and numerator will be just 56 there, times, it will be these two, 14 times 10, so that's 140, minus 2 times negative 2, so that's negative 2 negative 2, which is positive 4. So basically like that, and the other two, this one, there is a 0 here, multiplied, getting 0 0 0, getting 0. Similarly, when this one comes, this one, and this one multiplied, so other two will be 0. So basically like that. So once we do this, what I get, I1, what I got actually is 8 milliamps. So that's the current there, the current, and since I1 is going counterclockwise and the voltage source has a minus here, plus here, so the current should be this way. So it is the current actually, I1 is the desired current, the current through the voltage source. So that's 8 milliamps.